Good morning, good afternoon, good evening, and hello, everybody. My name is Satoshi Sekine, and this is a kickoff meeting of SHINRA 2021 ML task. Thank you very much for your participation to this kickoff meeting. And this meeting will be recorded and maybe distributed through the homepage. Please allow us to do so. If you have a question and you don't want to show your face, etc., please make a question at the chat box. Okay, and otherwise, so this meeting will be organized like this. I will introduce the task for maybe 30 minutes, 40 minutes at the beginning. Then I will accept lots of questions. Hopefully lots of questions. And then we will have an invited talk from the professor, I hope my pronunciation is right, Fyong Le Hong. And he is the leader of the team who made the best results last year. So you can learn a lot from the method from him. Okay, so let's start. Okay, so task overview. So SHINRA 2021 ML task is Wikipedia classification task. The task is to classify Wikipedia pages into 221 extended named entity categories. It is a merge level. Some page has a merge level, categories. Okay, and target languages is 30 languages. So at the bottom, it's listed from English, Spanish, French, etc., up to Bulgarian. And you can choose one or you can choose 30. And then evaluation will be done by micro average F measure. Okay, and this is another way to show. So there are 30 language Wikipedia, and the total pages is 32 million pages in total. Okay, we want to ask you to categorize them into E&E categories. Like this is mountains, this is schools, this is a museum. You know how to do it all language at once, one by one, and you can choose 5 languages, etc. But this is a task. Okay, and the rule of the task is each Wikipedia page. So this is basic. Each Wikipedia page should be classified into 1 or more categories of E&E taxonomy, version 8.0, and use only leaf categories. So this E&E taxonomy is hierarchical. So don't choose organization, but company, which is a leaf node. Okay, and you should label ignored for non-Wikipedia main space pages like disaggregation page, redirect page, etc. Also, it's basically the same thing, but invalid format Wikipedia page should be omitted. We don't evaluate them. It's not the same thing. No namespace is specified, then it's invalid. Okay, there's a namespace tag in the Wikipedia. So if it doesn't have, then you can ignore them. We are not evaluating them. Okay, and oops. Okay, and this task, SHINRA 2021 task, is exactly the same as SHINRA 2020 ML task, last year's task, except, okay, optionally, you can use the system outputs of SHINRA 2020 ML participants. It's already available. It's on the web page, and you can use them. And by those outputs, you can try ensemble run, for example. And also, we are preparing development data, which will be distributed. And you can, for example, do lots of experiments or use this for paper writing and so on. So we are preparing 200 pages for each language. And from the first last year's evaluation, we found that some category definition is very ambiguous. And evaluation was modified for 2 sets of ambiguous categories. City and prefecture, these 2 categories are very ambiguous for some countries. So we are not evaluating them together. We are evaluating them together, or concept and living things category. So I'm going to explain this later. Okay, and you can participate only light task. So last year we have only main task, and some people participate only the leaderboard. But this year we are evaluating the people who only participate leaderboard as well. Okay, so we prepare light task. Okay, and this is extended name entity. You can look at all the definition here, but it's a 3-layer name entity hierarchy ontology. And for example, there's a products, under the products, there's a vehicle, and vehicle has a ship, a car, train, aircraft, spaceship, ship, vehicle, other, etc. So this is the hierarchy, the targeting to categorize. Okay, and we are preparing training data, and we are preparing the evaluation data as well. And training data is created by this. So we have already categorized all Japanese Wikipedia, 920,000 pages. It's already categorized. And in the Wikipedia, there's an interlanguage link. So this page, like Tokyo city is prefecture, then it's a prefecture in maybe German data as well. So using this interlanguage link, out of 920,000 Japanese page, there's a link to German page 316,000 times. So automatically we can create 316,000 training data for German. Okay, it's a little bit noisy, but that's good enough, I believe. Okay, and what participants will do is create a system which use this as a training data, German training data, then outputs about 2 million pages, German pages, which has no link from Japanese. Okay, I ask you to annotate this training data as well, but this system outputs is here, 2 million pages. And against this, we have evaluation data. Of course, we are not annotated all of the data, but we prepare 1,000 pages for each language. And we are evaluating based on this 1,000 pages to your system outputs. Okay, we are not open, make this, which 1,000 is going to be the evaluation data. This is hide, secret, so that you should annotate all of these pages. And the final purpose is we want to make this output to the resource by combining all the outputs. I'm going to explain that later as well. Okay, and in case of German, I explained that there are 2.2 million pages and etc. 316,000 page has a link from Japanese. But these are all 30 languages, and so actually 31 languages including Japanese. And for example, in case of Bulgarian, there are 248,000 pages, Wikipedia pages in Wikipedia. And the link from Japanese is 93,000. So 37% of the data has a link, is going to be the training data. And I believe the text categorization task, not so many integration has this much training data. So this is unique. And I hope that you can achieve a very high accuracy. Okay, we are distributing lots of data. Japanese Wikipedia already categorized, language link data, 30 language training data. Okay, actually this 30 language training data can be created from Japanese Wikipedia and language link, but we distributing this training data as well. Okay, we preparing the development data and also Wikipedia contents in 31 languages, including Japanese. And in 2 formats, Wikipedia dump in XML format and serious search dump in JSON format. And the definition of extended name entity is also available. And for this year, the system outputs, plural, from SHINRA 2020 ML task is also available. Okay, all of this Wikipedia data is timestamp of all Wikipedia related data is January 2019. So don't use the current Wikipedia, but use this data. Okay, maybe the category changed or entries are changed. Okay, so and this is a format of training data. It's in JSON format. So this is German, Prefecture Tokyo. I believe the maybe pronunciation wrong, but Tokyo City Prefecture. And this is Japanese title, Japanese page ID. This is German page ID. And this was hand annotated. And named entity category is 1.5.1.2, which is province. Okay. In case of this book, dark line prints, it has to be categorized into 4 categories: movie, book, broadcast, program, and show. Okay, and then, yeah, this year we are distributing the results from the last year. So you can try ensemble learning, for example. And yeah, you can access all system outputs as well as all training data and development data for your research. Lots of books or papers about ensemble learning, so you can do this. But this is optional. And of course, you can participate without system output. You create a system from scratch without looking at the previous outputs. And because the results will be reported separately. So you can try, just create a machine learning system to annotate, categorize Wikipedia pages, or you can try ensemble learning, or both. Okay. And at the beginning, I said there's some mistake, not mistake, some problems in 2020 ML task results. And there are 2 ambiguous categories. Well, first one is city and province. Now, this distinction is not clear for some countries. We will merge these 2 categories and no penalty will be given if the system confuses these 2 categories. So you can, so the training data has a city category or province category, and you can you can create a machine learning system which outputs both, but we will not give penalty even if you answer city for the province or answer province for the city. Okay, and the living thing and 2 concept. Entities in subcategories of living thing, for example, insects or mammal, are supposed to be categorized into concept, not, for example, mammal or insect. But we found many ambiguity here and annotation errors in the training data. So if system outputs any subcategories of living things, there are mammal, fish, birds, etc., to the entities in concepts. So some upper level concept which shouldn't be categorized into fish, for example, or mammal, then no penalty will be given. Okay, so these 2 are the slight modification in the evaluation data. And for the last year's evaluation results, we will provide the results, the score, based on this modification very soon. And last year, this is last year's result, leaderboard. So we are preparing leaderboard. We try to make it by today, but it's still under construction. And when it's ready, we will announce it. Okay, and this leaderboard is from the last year's one. 7, for example, in this case, these languages, 7 people participated, submit the results, etc. Okay, so you can try your algorithm to see if you're making improvements or not, or where you're located in among the teams. Okay, and based on light task, we decided to have, based on the leaderboard, we decided to have light task. If you participate leaderboard, you automatically participate light task. And light evaluation will be done on the hidden evaluation data for the leaderboard, from the leaderboard and the main task participants. So main task participants also will be evaluated in this light task so that you can, we can compare all these participants, all our participants. But the leaderboard participants are not evaluated on the main task. The evaluation data are slightly different. Okay, and the results will be reported to the participants, and they have a chance to report their system at the final report meeting, which will be held in December. Okay, and we have released the data in March, and today we have a kickoff meeting. And very soon the leaderboard will be open. And we are thinking to do this brief session. Some question answer, or some people can present their primary system, etc. That has been done in the past SHINRA projects. I'm not sure, I'm not quite sure yet, but we hope we can do it. Okay, and result submission deadline is October 15th. And November 15th, the evaluation results will be back to participants. We will give you back the results. Then in December, our final report meeting will be held. Okay, and in order to help you develop the system, I report briefly the results from 2020. Okay, in 2020, 10 groups participated, 3 only on leaderboard, from Japan, Vietnam, India, etc., etc. University company and research institute, and many people, actually 4 groups participate for 30 languages, 2 groups participate only 1 language, etc. Okay, these are the distribution of languages. Okay, and this is the results. Actually, the FPTAI, which use a BERT system, dominates most of the categories. They are #1 on most of the categories. And actually, the leader of this team will give us an invited talk, so you can listen to what they have produced. Okay, and what is good from the results is that this is the best results, and this is majority voting F1 score. So we have so many participants, 10 or 7, depending on languages. And we do majority voting among these participants, which is most of the time, maybe 2/3 of the time, more than half of the time, the majority voting is better than single system. So we hope, we believe that all the effort will be useful to create better results. Okay, and then also we do error analysis, and the next 3 slides talking about that. So categories of many errors. So which is the most difficult category? Which is ignored. That's not ambiguous page, redirect page, etc. And product order is difficult. Concept, which is usually common nouns, are difficult ones. Doctrine, method, order, theory, competition, okay, etc. And top 9 categories, these ones account for about 50% of the total errors. So these are the categories you want to tackle. Okay, and one thing when we analyze the results, we found that many ignored errors could be solved by very simple rule. Disambiguation page, list page, number page, just 1 line pattern matching. You can solve this kind of problem that's ignored. And we believe 1% improvement can be done by this. Okay. Also, we analyzed training data size and accuracy. Of course, if you can expect that once the training data is bigger, the accuracy should be bigger. And basically, the results follow that principle. So if the training data has more than 100,000, 93.37% system accuracy, this is majority voting results. Between 50,000 to 100,000, It's 65 points. This is a little exceptional. And 95, 94, and these are good. So more than 20,000 training data results are generally good. And between 20,000 to 2,000, the result is 65 to 68. And if less than 2,000, the result is 43. So very intuitive, except two categories. So in this column, 6 categories, I'm sorry. Number category 6, so 65%. 2 of them are actually ignored and product other. If we exclude these 2 categories, the result is 92. So these 2 categories are very difficult ones. So excluding that 92.44. So still, because the data is majority large, the percentage, even the percentage is high, there are lots of errors. But maybe this area between 2,000 to 20,000, we want to see some improvements here. Okay. And the final one is inter-annotator agreements. Okay. So by categories. So which categories are which categories are difficult even for human? So doctrine, method other, product other, channel, character, etc. These are difficult ones. Okay, maybe even if you try machine learning very hard, you may not be able to make it better. It's interesting that the system is even better than annotator agreements, inter-annotator agreement, 84, but system accuracy is 97. Maybe this is based on the selection of data, etc. We don't know quite well, but that's something interesting. And also, this is an inter-annotator agreement, 96.3. Annotation accuracy is 98.1. So human are doing 98, but result right now is 85. Automatic method is about 85. So we have lots of improvement, room to improve. Okay, annotator agreements of 11 categories are less than 90. So these 11 categories are difficult one. Okay, so this is explanation from 2020. And I'm a little bit talking about what is SHINRA project. SHINRA project is aiming to make an explanation in AI. And this is famous Jeopardy question. Jeopardy quiz, IBM Watson tried to beat human champion of Jeopardy into 2011. Okay, and this is one of the questions which the Watson make a wrong answer. US cities, its largest airport is named for World War II hero. Its second largest for the World War II battle. That's a question. And IBM Watson answered Toronto, which is wrong. Okay. By the system, of course, they create a machine learning, lots of machine learning, huge machine learning system. The only information we can get is Toronto 14%, Chicago 11%, Omaha 10%. But we want to create a system which can explain the decision they made. Like, Toronto is the only city which came to my mind. I know it's wrong because it's a city in Canada, not in the US. Its largest airport is Toronto Pearson International Airport. Pearson is named for the 14th Prime Minister of Canada, blah, blah, blah. So this is the explanation we want to create. But at this moment, I believe no deep learning method or machine learning method can create this kind of explanation. Because in order to make this kind of explanation, I believe we need knowledge like this. So this is entity about Toronto, which is located in country Canada, and which has an airport, Pearson International Airport, one of them. And Pearson International Airport is located in Ontario, and name origin is Lester P. Pearson, and Lester P. Pearson is this kind of person. Okay, this is knowledge base, clearly, knowledge graph, maybe you can say. And many knowledge base developed, DBpedia, Freebase, Wikidata, Yago, Babelnet, etc. But these are very noisy. not so many NLP developers actually use this kind of knowledge yet. And we want to change this situation. Okay, we want to create this kind of knowledge base. Okay, why it's noisy? Because they use crowd. That's good. Crowd can help populating lots of contents. But design itself has to be created by somebody in order to keep the consistency. Okay, so we use the name ontology, which is extended name entity. I believe it's well designed. Then we want to populate the information or knowledge base based on this design. Okay, so that's a SHINRA project. But creating knowledge base is a big task, and it's laborious. It needs lots of money. But look at us. We NLP researchers has a technology to create that. Okay, maybe one system is not good enough, but you can do it together. And one of the way to do it together is evaluation project or shared task. So we will prepare training test data like the shared task, and we will not open the test data so that the participant has to run the system for the entire resource. Okay, that's why I said that the test data is secret. And the output of participants are gathered, and we create the resource using all of them, like ensemble learning. So we tried ensemble learning ourselves, but you can try that too. Some participants who are interested in ensemble learning, you can try that as well. Okay, and we can apply active learning or bootstrapping. Once the result is created, you can use this output as silver data, for example, etc. And we call this kind of scheme as resource by collaborative contribution. Let's make it together, not just evaluation. Okay, let's make resource together. Okay, and this effort has started in 2017. And 2018, we have a Japanese task, and 2019, 2020 as well. And from 2020, last year, we started categorization task for 30 languages, and we continue this for this year. And this year, actually in Japanese, we are doing the new task, find link for attribute values. So once we extract value like this, so up to last year, the task is to extract Pearson International Airport, but no allow like that. So the task for this year's Japanese task is putting this kind of arrow. Okay. Okay, and yeah, this is another example that ensemble learning works. So this is a result from SHINRA 2018 Japanese task. And these red numbers are the best results from the participant, but ensemble results is like in kind of compound, chemical compound, 18%, 18 F measure better than just single systems, 47 improved to 65. So making together worked. So I hope you help us doing that. Okay, these are the organizers. So we have lots of people there. Thank you very much. And this is the link, SHINRA ML homepage. Okay, you can search SHINRA 2021 ML, or you can go this URL and the leaderboard here, which will be available soon. And we are preparing email by us. So if you have a question, comments, etc., please send email to this address. And this is announcement email, so you can participate this. And we also are creating the mailing list for the participants. And we prepare also the Slack so that you can discuss with us. We are happy to help. For example, if you want to know more about the statistics, error analysis from last year, you can discuss that in this Slack. Okay, so this is all about the task. And if any of you have questions, please raise your hands or make chat or unmute and speak yourself right now. Thank you very much. Any questions, comments?
May I have is it okay to make a question?
Yes, Yoshiko-san, thank you very much.
Yeah, so thank you for setting up some big task for finding out, extracting knowledge from Wikipedia. And I have some questions about the, you were talking about some accuracy based on the category of with some training examples. So maybe I'd like to, so that kind of information is something is good to start up about the discussion about the which kind of categories are very difficult to distinguish. Yeah, as you mentioned, some product other is a very difficult category because this is the other category. Yeah, if you think, if you just training by using some, it's a kind of training data and some machine learning, just say this is a level. In such a case, it's a very difficult task because it should be those kind of categories should be recognized as it should be categorized as a product and not belong to the others, some particular categories, and that should be categorized as a product other. So because of such a kind of things, we would like to know which kind of categories are very difficult to distinguish, and such kind of information is much more helpful, and some confusion matrix or which kind of data is something that becomes too confused. I suppose some city and prefecture or some kind of new evaluation scheme was proposed based on the analysis, but it is interesting to share such kind of information for discussing about what is a difficult classification category or what is easy and so on. And that's, do you have any information you can provide at this moment?
Yes, thank you very much. We are definitely provide the confusion metrics that could be helpful. Yeah, definitely. And also we analyze several category confusions, product other and concept, for example, are the difficult ones. So we will give you some information from the people who analyze it. So they are annotator, of course, and they know the category very well. So, and they basically say it's really difficult for the people as well, etc. And yes, for those who doesn't know this extended name entities. So extended name entity is a category like this, 221 categories. Product has a lots of things, video work, musical instrument, clothing, etc. But also it has a product other. And event has an event other, facility has a facility other, and all intermediate node has other category. That was created because of the long tail problem. There are many kinds of products, and we can't create all the category or all the subcategories for products. So the minor ones are put together into product other. That's other category, and that exists for all the categories all the intermediate category in this hierarchy. And these are really difficult ones, as Yoshioka-san said, because these are something other than other things or certain things. So even training data, there are many different kinds of things. If you're lucky, if it's not lucky, then there's not exactly that kind of thing in the training data, but you have to find that is a product other. So these are very difficult, and you better to understand that. The hope someone can come up with algorithm which find that kind of other entities very well. I don't know. I don't have answer. Of course, if I have answer, or I already done it. So this is really difficult one. as you can see, lots of difficult ones as other category: product other, doctrine method other, hood other, GPE other. So these are difficult ones, and that's all I can say. And of course, I will. Oh, by the way, this slide is available on the homepage already, and the statistic of small, not confusion matrix, but about these data, the source data which can extract this kind of information is already available from the homepage. So you can go there. You can calculate this kind of thing. You can see all the data below these 11 categories. So please utilize this information and make a better system if you can. Okay, hope that helps. That's answer your question. I cannot really answer your question, but I'm happy to provide as many information as possible.
Thank you.
Thank you. Okay, any other questions? Yes, so we are really happy to get a comments and help you to do something better for you. So we if you need, if you can say, oh, I need this kind of information, I need this, I want to have, I don't know, some help. And we have several people already working on this. So we can give you advice, or you can do some instruction, help, etc. If you're a PhD student, a master student who wants to try this, I'm very happy to help you.
If no question, I would like to ask one additional question related to this. So yeah, in the gold standard data of Japanese Wikipedia, have a two types of information. One is hand-picked and annotated, and the other is machine generated. And the machine generated have something we suppose that machine generated data have similar characteristics of this type of errors.
Actually, not really. So yeah, it says hand annotated. So this is a stamp indicating that this information was created by hand or automatic. But almost all the automatic ones are actually checked by hand. And only exception, I believe, is, for example, if some systematic analysis can make the prediction more than 99.5% or more. So we checked 200 example and there's no exception, then we apply that rule to create automatic answer. I believe that hasn't have so much errors, and yeah, so automatic system actually was created by Mr. Suzuki about 4 or 5 years ago. That was presented at some conferences. You can check from the homepage, but that method is also good. You can learn. I believe the source code is also available. I'm sorry if I'm wrong. So you can try that as well, or but I don't think there's not so much difference. Actually, annotators really look at almost all the data.
Yeah, but some small size of groups may contain some problematic data.
Okay.
So, but yeah, so yeah, that may also, yeah, I'm not sure that affects for the errors for the latter part, but not. But yeah, that is that may be a effect for such kind of things. Maybe exists or not. I'm not sure. And one additional thing is for the multiple categories. And there are categories like pages that have an animation and character for the page.
Yeah,
that kind of page was in Japanese Wikipedia. Those two contain that same one page, but for the other countries, it was separated. Mm-hmm. There should be another cases. One page was corresponding to several pages. So have you checked such a kind of effect in this data?
No, we haven't checked that kind of things. That's true. So that's why I said the training data we created like this is silver, not really 100% gold. Yeah, sometimes in case of sometimes Japanese page is talking about, I don't know, people, but in other page it's kind of events. That can happen. I believe it's very, very minor. So yes, so this this might affect the results, but we are not assessing. I don't know how to unless I check all the data again.
Yeah, maybe the majority voting says some one category, but the result is totally different. Yeah, that may be a strong clue to check. That kind of data.
Yeah. Okay, that's good. Thank you.
Yeah, that's a comment. So.
Okay, great. Thank you very much. And any other questions? Okay, if not, I will proceed to the invited talk. And then after that, I will accept questions if any of you have. So invited talk will be given by Professor Lee Hong Hyung, and title is Crossing Up Representation Learning for Multi-Level Text Classification. And he's in Hanoi. He's participating from Vietnam. And he's a leader of the team which made the best results in most of the categories at SHINRA 2020 multilingual task, as I said. And okay, this is the bio, but I know that he has a time limitation. So and I asked 30 minutes talk. So this is, we should start right now. Okay, this page is available, so please read if you're interested in him. And he's a great researcher in Vietnamese language, and he created a tool, as far as I know, he created a tool for Vietnamese language analysis. Okay, so Hyung, can you give us a talk?
So thank you very much, Professor Sekine, to invite me and to introduce me to this very interesting project, the SHINRA. And in this talk, I'd like to share with you some of my some introspection about how I and my team, my college at the university and the company, the APT company, tackle the task, and we are delighted that we get a quite good result overall. And I'd like to share with you some thoughts, some perspective for the SHINRA 21. And secondly, I'd like to introduce some applications, practical applications of the ideas and the result that we got within our APT AI platform to bring back some value to the SHINRA, the method that we developed at SHINRA to our commercial platform, AI platforms, and vice versa. So I will go very quickly on the retrospection because we have a technical report and the papers that describe clearly, or I think in detail, the approach. So here in this talk, I schemed the model, the task, the model that we developed. First, so last year we participated in all of the 30 languages for the first task, and we got the first rank for the 25 over 30. There are 5 languages that we do not the number 1, but the gaps, the performance gaps are quite close. But that suggests a lot of work to do in the next task of SHINRA 21. So we know that this is a multi-label classification task where we have cross-covariant type and 5-covariant type for INI, extended identity type. And the distribution of the category here is very sparse, is very skewed towards some the higher level and the deeper level of the category. So we need to think about some specific method to deal with this crude data set. And so the main idea of our proposed method is that we have 3 stages. First, we train the multi-language model on all the 30 languages using the BERT, the multi-language BERT. So that's quite popular, I think, not only at that time, last year, but also today. So, and the second step is that we fine-tune that multi-language model for each language, each target language. And the interesting thing is that we use the same architecture, the same BERT architecture, and the same technique for the multi-language model. And finally, we developed a simple voting method to perform the final classification. Here is the core. Here is the main model of our method that we have. You see here we have multi-language model, and we have mono-language model, but all of them have the same architecture. So we learn a hidden representation of Wikipedia page, and for the multi-language model, we use all the page of all the language, but for the mono-language model, we fine-tune on only the data set corresponding to the language, the target language. And I think an important component in our system is that we use a multi-label hierarchy classification method, or state-of-the-art method, to learn the dependencies between categories, cross-covariant and 5-covariant category. That's reflected in the right part of this figure. We have Y2, Y3, and Y4. That's the level, the label, different levels of the label, and thus we use BERT, and we use here we have HMCN, that's a neural network architecture for hierarchical multi-label classification. This method was published several years ago at ICML, and they are demonstrated just as a state-of-the-art classification for multi-class classification. And I think we utilize this method well. We can discover the local hierarchy relationship and the global information from the entire class hierarchy. And this method have also penalized the hierarchical violations. So I think so that we integrate into the model of the after learning the hidden representation of the page. So that's a core, and I think that the last one is that we use a very we use a kind of weighting technique, because when we develop our loss function, the normal loss function here we use cross entropy loss, very normal, but for each label there should be a weight associated to penalty for mistake. So that's idea I think it's very fruitful to train to have trained a better model, both multi-language model and mono-language model. So the weight here is calculated using a very simple technique that we cut off threshold on the vector, so the frequency vector. I think this is a small trick, but it's very useful. And the last one is that we use the voting techniques, very simple, like most of the ensemble learning technique. So we, because the advantage is that we perform the classification for all the 30 language. So we have more information on more than a system that process only one language. So and for that the voting is to count frequency and take the above the mean, and we chose the majority, and that is, and we think that we have a good result for 25 language. But we analyze the performance gaps with other top systems after the conference. Thank you very much for the organizers to distribute widely the result. And we see that the performance gap between our system with the top one, the top performance one is quite small, except for the Arabic language. We don't know why yet, because they were in our team, there's no one that speaks this language. So it's very difficult for us to analyze it further. And the best team for each language, as shown in the table, these are all the big language in the world. You see the French, English, Spanish, German, Arabic, all very important language. With we say that is a rich, the high resource language with many pages, and so that suggests that our system has much room to improve for improvement in this second participation. And we have also done an ablation analysis to see what technique bring improvements. We have the vanilla model embed. We add the hierarchy loss, and we add the weighting technique to the about that, and we add finally the voting technique. And the final result, we see that the weighting is very important. It improved by more than 2% for all the 30 languages, and the voting techniques increase about nearly 1%, and together they make our system perform better, much better than the baseline embed model. And that is, I think that's a retrospection about the last year's method. The key ideas is that we start with a very strong model. Here is the embed model. And second one is that we have a special treatment on the multi-label classification, which maximize the learning capacity between the label. We have a structured label data. And that's the second idea. And the third one is that we use a voting strategy, both in the process of selecting the threshold, we cut the threshold, and in performing the ensemble learning. And so there are more gaps, but we think that for perspective, we see that this system is designed specifically to handle all of the language using the same model, the same method. But it has shown to be very effective for low resource languages, including Vietnamese, that our language that we are concerned at the from scratch when we participate in this contest, in this task. But on the high resource language, it performed quite poorly in comparison to the best performing system. So we think that there is much room for fine-tuning this method using high resource language. And we think that in this year, there are some new developments on the model methods, the new models which are published in machine learning community in recent years. And we are thinking about also a technique that we have regularize the result. We think about the adversarial training methods, but it's a rough thinking only. We have not elaborated it very clearly, but I think that's a good way to improve the system further. And I'd like to spend some minutes introduce what we have applied, some kind of technique here in the commercial system, the name FT AI that are developed by our company. And we are in the team of NLP, Natural Language Processing. It's a very important team that serves the methodologies for the framework, the language processing framework for this platform. So, and we start from scratch from this is a multi-language AI platform. So I think the technique and models that we learn, the lessons that we learn from this SHINRA task is very important and very fruitful for developer further this system too. So FTAI offer many products and services, for example, virtual agent and call center, conversational AI platform, text-to-speech, speech-to-text. All of them need to deal with the natural language processing tools. And there are also image reader, the form reader, and eKYC for the e-commerce. And we have many big customers in Vietnam from 3 years since its launch. There are now more than 40, over 100 top enterprises in Vietnam that use this system to have automatic some related AI related task. For example, Vietnam Airlines, securities companies, Honda. So that's a big Japanese company that worldwide in Vietnam too. And this is currently there are very frequent use of this platform. About more than 50,000 programmers that use this platform daily. So serving more than 11 million end users for banking system, for many industry sector. And there are over 200 million API requests each year through this platform. And many of them are served by our natural language processing technique. And currently, this AI platform support English, Japanese, Bahasa Indonesia, and Bahasa Malaysia, and of course Vietnamese. And it will be available soon in French, Korean, and Thai. So we develop get more language. And it turned out that many natural language processing components we develop here. The two major ones is natural language understanding, where we want to extract the intents and entities from user utterance. Utterance are short text, but the way we can apply some method for long text like Wikipedia page that we are dealing with this project. Basically, we need to classify to detect the dialogue acts and intents for the conversational platform. And the second one is where we have a dialogue flow management that we need to handle state and context for to direct the dialogue flow in the conversational AI. And all of them need to perform many machine language models and natural language processing tools. And you can think of that we can effectively have some methods to exploit this technique in the context, in a multi-language, multilingual context, like intents and dialogue acts. All of them are classified in types and subtypes, and in many languages serving many customers. So I think that we bring some benefit from this participation in this task alone. Thank you so much, Professor Sukine, to let us know about this this project. And the second one is that I think it's more relevant. It's the most similar task that we are dealing with in this platform. We are developing a document tagging platform for this system, where we think we can think of that we have many documents. We have collections of documents in some areas like banking or investment document of banks, of the financial institutions, that order us to classify, to extract information from these millions of documents. And effectively, we consider this is the same problem that we are dealing with here in the classified Wikipedia page. That's a multi-label class document classification, where we need to assign the concepts that are predefined from the sector, from the investment banking, and we need to classify this document to have decision making. And it turns out that we can learn a lot, and we can bring the models to this kind of task. Despite that, we are working here currently in the monolingual language for Vietnamese only, but we think that's beneficial for us too with this technique here. So that's it. I think I conclude my talk here. I'm sorry because I don't have much time to present more detail in this talk. But I think we can share with you more detail later when we chat or we use email. And that's it. Thank you very much for the attention. Yeah, it's very much for you, Mr. Professor Sukine. Yeah.
Okay, thank you very much. I know that you have only 8 minutes or 6 minutes before you talk next meeting. But I'm very impressed by.
I'm sorry, I turned off my first time. I forgot that.
No, that's okay. You're very impressed by you are doing lots of things and lots of customers.
Yeah.
And I'm very impressed. Thank you very much. So if anybody has a very short questions, you can ask now, or maybe we can chat later from the organizer and the Professor Lê Hằng. But any other people or anybody wants to know more about their system? Is your system available on somewhere or GitHubs, or it's not open?
It is available on GitHub, but not the version that we use to produce this result here. We open our code for the FTAI core models. It's not for the SHINRA models. Yeah.
That's okay. Oh, wow, okay. That's nice. I like to make a pointer to the site.
Yeah.
Please let me know. I'm definitely that'll be definitely useful for many participants, new participants.
Yeah.
Right. Okay. Thank you.
Thank you.
Yeah, and it's really interesting that your results is very good at the minor language rather than bigger language.
Mm-hmm.
I like to know why in a year maybe. In a year you make a better system for all the languages.
Yeah. I think there is some change in our team. Some key people that go abroad to study, and we need to build from scratch a new team to tackle this project.
Right.
Yeah.
Thank you very much. I appreciate your participation, and let's talk more. And
yeah, okay. So thank you very much. I'm sorry I need to quit now because I have another planned meeting. Sorry for that. Yeah.
Thank you.
Okay. Okay. So thank you. Bye bye. Yeah.
Bye.
Bye.
Okay, so other people now, if you have any other questions to the task, not to the invited speech, please raise your hands right now. Method of automate annotations. Oh, thank you. There's a question about would you teach the method of automate annotation? Okay, it's in the paper, and I believe the source code is available, but I can't go directly to there. I'm not sure. Just to share. Okay. Okay, so this is SHINRA page, and I think there's a paper somewhere. I'm not here. Any SHINRA organizer, do you know publications related work? Okay, so here. Oh, no. It's done by Suzuki, and that should be, okay, I'll put that information at least here, but okay, how can I find? Sorry, very. Yeah, okay, so this is the one. A joint neural model for fine-grained name classification of Wikipedia article, 2018. So that is a paper. I'm sorry, this is Japanese site. Maybe not many of you can access this. Yeah, this is done like 2016, so very naive machine learning method, or maybe neural method. And I believe the system done by this FPTI, Le Hong's team, may have more contents. I'm not sure. Please look for this paper, and you can at least learn something there. Okay, thank you very much for the question. MH, the person MH. Okay, Masako, thank you. Okay, any other questions? Okay, if you are interested in participating in this task, we are very welcome. We will do as much as we can do, and we can discuss, and we can help any directions. So please go to the site, go to the homepage. Yeah, this homepage, and yeah, and you can call us by email. Yeah, there's a email address like contacts. So this is the one you can talk to. Okay, I can put it in chat. So I like to discuss with any of you. Okay, there's a question from Antoine Dao. Thank you very much. Dear Professor, do we have the same level for different language versions of the same Wikipedia page, or are there any alignment in the data set? So do we have the same level for different language version of the same Wikipedia page? For the training data, it is yes. We believe, or we assume that the same page, Tokyo City, is a Tokyo City anywhere, and the categories are the same. That's maybe wrong. So that's why we call this is silver data, not gold data. Okay, if that is your question, that is the answer. But in the test data, it may not. We annotate. Yeah, I don't want to disclose a way to create the test data because otherwise some people may tune towards that kind of information. But in the test data, it may not. that have the same level for the different version of different language version of the same Wikipedia page. Or are there any alignment in the data set? Alignment, I'm not sure the meaning of alignment. We are not aligned intentionally, or we will treat the Wikipedia as it is. So we are not changing any Wikipedia page and etc. I'm not sure. You can ask me by voice if you like to, or maybe you can send me email and I can answer to your question later.
Thank you, Professor. I understand the situation. What I ask is about, for example, we have Tokyo City Wikipedia, and it can have multiple versions in languages. And in your area, I assume that you will have multiple language based also.
Yeah, there is multiple language Wikipedia in maybe 30 languages. There's a Tokyo City. Yes. Yeah, you can yeah, there are, right, so there are lots of 238 languages has Tokyo City in the Wikipedia, right? So at least 30 languages we are targeting should have Tokyo City, yeah.
So in the data set, there is any ID that I can follow
ID.
that, yeah, or anything that I can align these bases in multiple languages.
I see. Okay. Yes, as I said that in the slide, I'll go back to slide. Yeah, so we are distributing data, Japanese Wikipedia and language link for 31 languages. So actually each of them has a page ID. I believe this is created by Wikipedia. And so the German page 187830 has a link from Japanese 774362 page, which is Tokyo City, and this is Prefecture Tokyo. So this is alignment, and this is one of the data we are providing. It's not a uniform ID, but we have a corresponding table between this number to this number.
I see. Thank you, Professor, for your explanation.
Okay, thank you. I'm glad that I explained it well so that you can understand. Okay, yeah, any question like that, please ask me so that you can work on the task smoothly. I'm very happy to help. Yeah, once you start dealing with this data, maybe you have a question and you have some difficulty processing the data. So please ask us, and please join the Slack. That may be the easiest way. We can share the information. You can go back and look at the previous questions, and that may solve your question. So I hope that many of you who may not participate in the evaluation, but who is interested in, who are thinking, maybe I can try, please join us by sending email to the information or etc. So that was available in the homepage here, or you can just send email to this one. We are here. Okay, everything clear? Any other questions or comments? Not really. Okay, then thank you very much for participation, all of you who stay until this end. And this video will be provided very soon. So if you want to look back, you can go there. And hope you join this effort together. Okay, thank you very much, and have a good day, or have a good evening, have a good afternoon, etc. Okay, thank you very much.